through consistently as frequently as possible to make sure as we get to more complex equations, we're good to go. When we are solving an equation, it is based on one concept in the fact that we need to use inverse operations. Inverse operations are operations that will undo each other. Okay, so if I have $20 and I give Carson $20. I'm not giving him $20, sorry. Okay, to undo that operation, what would Carson need to do? Give me the $20 back.
Or steal it.
Right? No. So that's our whole entire objective, is how would we undo what we just did? Okay, and inverse operations are addition and subtraction. They undo each other. Right? If I add 20 to undo it, I take away 20. And multiplication and division undo each other. There are other inverse operations. We're just not going to need them yet. Okay, it's also important to understand that we can't undo pieces in any random order. Okay, what we need to do is we need to do order of operations backwards. So most of us know PEMDAS for order of operations. So PEMDAS backwards is going to be SADMEP. Except I'm writing it kind of weird. Right? It's just PEMDAS, P-E-M-D-A-S. But backwards it's SADMEP. I don't know how else you would say it, but whatever. Okay, and this says that whenever we are going to solve an equation, we are going to undo addition and subtraction first. Okay, we will undo multiplication and division second. The E we don't need to worry about because that's not a property we're going to be dealing with yet. And we will undo anything in parentheses last. So if we're looking at a one-step equation, there's only one piece to undo, and therefore we don't really need to consider order. So if we have something like y plus 3 equals 8. Again, I'm picking simple numbers to help keep us from dealing with complex things, but again, our underlying objective is to always show our work to build a solid platform. Okay, our objective is going to be to get y by itself. Whatever the letter is, whatever the variable is, we want to get it by itself on one side of the equal sign. Okay, and to do that, that means whatever is happening on the same side of the equal sign with the variable, we need to move to the other side of the equal sign. And our rule across the board every time is whatever we do to one side of the equal sign, we also have to do to the other side. And we're going to do that with inverse operations. So this says that we are adding 3 to y. So what operation did we say was the inverse of addition? Subtraction. Right? If you're not for sure, keep this list handy. And it's okay if you're not for sure. Right? We have people across the board in tons of different places. It's okay. Okay, so our opposite or inverse of addition is subtraction. So underneath our adding 3, we are going to use our inverse operation, which is subtracting 3. Right? And those are going to cancel each other out. Whatever we write over here, we have to write on the other side of the equal sign. Can't do it on just one side. You have to do it on both sides every time. Right? 3 minus 3 just goes away. It becomes 0. So over here, all we have left is our y equals 5. 8 minus 3 is 5. Use your calculator if you need to. Because here is then the deal. My students tell me, oh, no problem, Mrs. McKinney. I can do that. There's no issue. And then I give them this problem. And they go, nope, I don't do fractions, Mrs. McKinney. Fractions are not my thing. Nope, turn the page. Okay, but we just spent time making sure that we could use our calculator to help us deal with fractions. The reason is not to say, oh, you're dumb, you can't do fractions. Okay, the reason is because this is always what I picture in my brain. My husband makes fun of me, but I sort of picture this old man in my brain. You know, it's like the guy from Up. You guys seen Up, the cartoon? Who's like trying to retrieve information in my brain. He's old. He doesn't move very fast. My brain processes relatively slow sometimes. Okay, my old man can't retrieve information about how I deal with fractions and get information over here in my brain about how I solve equations. So use the calculator so you don't have to think about the fraction, so that your old man can just look in the filing cabinet to find information about solving equations. Don't worry that there's a fraction. Ignore that that's even a fact. Go back to the same rule. We want to solve this for W. What number is over here with W? Lily? 3/7. How do we undo subtracting 3/7? We're going to add it. Don't worry that we don't like fractions. It doesn't matter. We're going to let the calculator do that work for us. Okay, whatever we write on one side, we have to write on the other. And so we know these things will cancel each other out just because we know that that's what inverse operations do. Okay, and then we will pick up our calculator and we will type in 2ABC1, ABC5 plus 3ABC7 equals, and it will just tell you the answer. And we'll get 2 and 22 35ths. When we're dealing with equations, it doesn't really matter whether we have the variable first or second. Just realize that this is the same thing as this. Okay, if you needed to change it in a different form because Alex says enter it as an improper fraction, right? You could do that on your calculator too. Okay, and the student's like, sweet, I can take care of fractions. That makes sense. And then what happens if we're given this problem? And my students go, ugh, 2 operations? Yeah, nope. I don't do 2 operations, Mrs. McKinney, skip. Okay, again, the idea is exactly the same. You have two choices though as to how you can do this. Okay? Choice number one is to do exactly what we've been doing. To get a by itself, we undo addition with subtraction, and we would subtract -17. However, the majority of the time, my students don't like to deal with two signs side by side. Okay, so I'm just going to give you a rule to clean it up. You're a rule worker here. Here's your rule. If the two signs are the same sign, it's going to turn into one addition sign. If the two signs are opposite signs, it's going to turn into one subtraction sign. If you know your multiplication rules, that's exactly what we're doing. A positive times a negative is a negative, right? These are opposite signs, so we can just write this with one sign in there. Okay, so what's our variable up here? A. What number's over here with it? How do we undo subtracting 17? I'm going to do that on each side. I'm going to tell you right now, if you don't trust yourself with negatives, don't trust yourselves with negatives and put that in your calculator. Right? Put in -22 plus 17, which gives us -5. Okay? How are we doing so far? Addition has more tricky pieces than multiplication and division. Multiplication and division is pretty straightforward when we solve those. Okay, we have one tricky piece with fractions we're going to talk about. Well, that's a weird 3, but whatever. How about 3b equals -12? What operation is holding that 3 to the b? What'd you say, Ellie? Y. Right? So when we don't see a sign here at all, no operation means multiplication. So if we want to get the b by itself, we're going to undo multiplication with division. Division at this point in life, we pretty much always write as a fraction bar, but I would not count you wrong if you wrote a different type of division sign. We're going to do that on both sides. Again, if you need to use a calculator, use a calculator, right? But -12 divided by 3 is -4.
So instead of writing it with 2 3s, is it okay if you just draw like one line and put 3 underneath it?
Here's what I'm going to say. I'm not super picky about that.
Okay.
Because you're showing me that it's division. You are going to get teachers once you leave that room, this room, that would count that wrong. Because you're technically not writing it on both sides, and it isn't technically a correct way that we would mathematically write it. I'm not going to say anything in here.
I just think it's easier.
Right. I mean, it's fine in here. I don't want to say yes, and then you'd be like, oh, but my other teachers, right? So you just have to kind of be careful there.
Okay.
So here's another one of those where my students go, yep, fractions are not my friends. Okay, you'll hear me say all the time, fractions are our friends, they're numbers too. Treat them just like anything else, it's fine. There are a couple ways that we can deal with fractions. Okay, if you know how to multiply with fractions without a calculator, you'll know that when you divide by a fraction, you're really multiplying by the reciprocal. And so you'll often see Alex as an explanation, teachers talking about multiplying this by 3 over 2. But the reality is most of us don't know how to multiply with fractions anyways, and we're going to use our calculator anyways. So it's really not important. There are other ways to solve this. If you want to get this W by itself, this says 2/3 times W. And how do we undo multiplication? Divide. So it's okay if you divide this entire thing by 2/3. Right? You can type into your calculator 8 divided by 2/3. Dividing by 2/3 is the same thing as multiplying by 3/2. So it doesn't matter to me what you do. It's up to you if you have a preference. If you have a way that you already are multiplying by the reciprocal, by all means use it. But this is fine as well. You okay on that one? So what if I put some operations together? Y plus 6 equals 14. So now we have multiple things happening, right? We have multiplication and we have addition. So 2 operations. We said that we want to do order of operations backwards, right? That's SADMEP. So we're going to undo any addition or subtraction first. One of the biggest issues I see with my students is that once multiple things show up in the equation, they're not sure where they want to start. Okay, you can use your calculator, your hand, whatever. Okay, if you draw a line down here at the equal sign, you only want your eyeballs to focus on the side that the variable's on. So if I ignore this here, I'm going to focus my eyeballs over here. This number is irrelevant for the time being because it's not the same side that the variable is on. Okay, and I'm going to look over here and I'm going to tell myself, okay, I want to undo addition and subtraction first. So do I see any addition or subtraction?